Hello and welcome to UGCE PG Pathshala. I am Anushri Nagpal from the Department of Geography, Jamia Millia Islamia. In this episode, we will learn about thunderstorms and lightning under the paper Disaster Management. Learning objectives. Number 1, to understand the phenomena of thunderstorm and lightning. Number 2, to explore the impact of lightning. Number 3, to get to know the global and national scenario of lightning. Number 4, to understand different preventive measures. Phenomena of thunderstorm and lightning. A thunderstorm is a storm associated with lightning and thunder. They are typical atmospheric phenomena and tend to be highly localized. It is generated within the clouds and thus prevention is beyond the human control. From a purely disaster management point of view, the main hazard is lightning and not the thunderstorm. Thus, in this module, we shall focus more on the hazards caused due to lightning. Thunderstorms form within a warm, moist air rising in an unstable environment. As long as rising air becomes warmer and less dense than the surrounding air, there is upward directed buoyant force acting on it. The warmer the air as compared to its surrounding, the greater the buoyant force and the convection. The triggering forces needed to start air movement upwards can be one of the following. Number 1, random turbulent eddies that lift small bubbles of air. Number 2, unequal heating at the surface. Number 3, the effect of terrain such as small hills or the lifting of air along shallow boundaries of converging surface winds. Number 4, large-scale uplift among the mountain barriers and rising terrain. Number 5, diverging upper air winds coupled with converging surface winds and rising air. Number 6, warm air rising along a frontal zone. Normally, combination of these phenomena triggers with vertical wind shear to generate severe thunderstorms. Lightning is a discharge of electricity, a giant spark which usually occurs in the mature thunderstorm. Lightning may take place within a cloud, from one cloud to another, from a cloud to surrounding air or from a cloud to the ground. Lightning results from a strong separation of an electric charge that builds up between the top and the bottom of the cumulonimbus clouds. Air carrying water droplets and ice particles move towards the top of the cumulonimbus clouds where they clash with the downward moving ice particles or hail. In this process, strong positive charge usually carried by top of the cloud interacts with the lower part of the cloud that carries strong negative charge. Negative and positive charges attract one another. A negative electrical charge may attract the positive charged cloud top or to the positive charged ground. This generates electrical charges in terms of millions of volts. At one point of time, the electrical resistance in the air cannot keep these opposite charges separate from each other. It results in positive and negative regions joining with an electric lightning strike. A person standing on the ground will always see lightning first and then hear the thunder sound, though both occur at the same time. This is due to the fact that light travels at a speed of around 300 crore meters per second, while sound which travels at a speed of 340 meters per second. So the light is visible before the lightning sound. Impact of lightning. The critical impact of lightning is death and injuries, but more than that, economic damages arising out of lightning are worth mentioning. Lightning causes damages worth of billions of rupees in housing, agriculture, industrial and public sectors. Lightning strikes can injure humans in the following ways. Number 1, direct strikes. The person falls in the path of the lightning strike. Due to the passage of enormous energy through the body, this kind of event results in severe burns and damaged nervous system and is often fatal. Second, contact injury occurs when the person touches any object which was electrified by the lightning strike. Third, side splash. Branches coming off from the primary flash channel injuring the person. Fourth, blast injuries occurs when the person is impacted by the blunt force trauma of the lightning strike. Fifth, step potential. Once the discharge occurs, the earth's surface charges race towards the spot of lightning strike. Ground provides high resistance. To avoid this, the charges follow a better conductor. in case it is present in the path. The near instantaneous rate of discharge causes a potential difference over distance which may amount to several thousand volts per linear foot. This phenomena is responsible for more injuries and deaths than the above three combined. This is according to the NDMA 2015. The discharge also produces electromagnetic pulses which can damage an artificial pacemaker and affect normal biological processes. If there is a direct lightning strike to a structure, then the types of damages include A. Injuries to living being by electric shock as a result of touch and step voltage. B. Fire, explosion, mechanical and chemical reactions as a result of the physical effects of the lightning discharge. C. Failure of electrical and electronic systems due to surges. Second, if there is a lightning strike near a structure, then the types of damages include A. Failure of electrical and electronic systems due to surges. Third, if there is a strike lightning to an incoming line, then the types of damage include A. Injuries to living being by electric shock as a result of touch and step voltage. B. Fire, explosion, mechanical and chemical reactions as a result of the physical effects of the lightning discharge. C. Failure of electrical and electronic systems due to surges. Fourth, if there is a lightning strike near an incoming line, then the types of damages include A. Failure of electrical and electronic systems due to surges. The kind of losses resulting from these types of events include loss of human life, loss of service to the public, loss of cultural heritage, loss of economic value, etc. While loss of human lives include injury or death of a person, loss of economic value primarily includes loss of agricultural properties like farms, animals, etc. Individuals surviving the immediate effects may develop lightning syndrome. It is characterized by unconsciousness, temporary impairment of central and peripheral nervous system functions, conductive deafness, and skin burns, etc. People involved in agricultural activities, grazing animals, forest workers, homeless and nomads are particularly vulnerable to lightning. Hailstorm is another phenomena associated with thunderstorms. Hailstones are solid chunks of ice having varying size which is produced during thunderstorms. It does not induce human life loss or major injuries but is considered as major hazard in India due to the economic losses associated with it, mainly in the agricultural sector. Global scenario of lightning. Lightning is a common occurrence especially in tropical and subtropical regions which results in the massive number of deaths per year. It occurs intermittently throughout the year. Global estimates range from 6,000 to 24,000 fatalities per year due to lightning strikes. But it is to be noted that there has been little systematic collection of information on lightning deaths in many regions of the world, making it difficult to give correct estimates. Figure 1 compares the rate of lightning fatalities in India with other countries of the world. The number of fatalities have been taken from different publications all over the world. According to the figure, the number of lightning deaths in different nations for certain periods of time has been recorded. The time period is non-uniform due to the lack of data, but it provides a rough estimate of the average annual death rate per million people. As per the figure for a given period, the lightning fatalities occurring in India, China and the United States of America are 5,259, 5,033 and 3,239 respectively. But highest number of average annual deaths per million people is of Swaziland with 15.5 followed by Zimbabwe at 13.4. In comparison to Swaziland, India have very low average annual death rate per million people with number of 0.25. Lightning in Indian context. The investigation shows that a total of 5,259 fatalities were observed as a result of lightning strikes occurring from the year 1979 to 2011. The average fatality per year in India is 159. States like Maharashtra, Kerala, West Bengal, Uttar Pradesh and Karnataka are having the highest lightning casualty risks. The number of fatalities due to lightning varies across seasons as well. In the monsoon season lasting from June to September, 57% of lightning fatalities were recorded, while 31% of lightning fatalities occurred in summer or pre-monsoon, that is from March to May phase, post-monsoon from October to November, and winter from December to February corresponds for a relatively small number of fatalities. It is interesting to note that during the year 1979 to 2011, far more males, 89%, than females, 5%, have been killed by lightning flashes in India. The reason attributed to this is a relatively higher work participation by males in traditional tasks like agricultural work, construction work, etc., and more exposure to outdoor activities and recreational activities. In spite of the massive impacts of lightning, the severity associated with the hazard and its risk perception is low. Lightning is a very localized and isolated event. Deaths from lightning are normally single event and it affects very few people at the same place at the same time, unlike hazards of earthquake, flood, cyclone, etc. Thus, in spite of the total death toll of lightning being very high, it is often misses to grab attention due to its dispersed nature. Lightning hazard prevention mechanisms. After observing various data sets highlighting the risk of lightning in India, it is necessary to talk about the preventive measures for lightning. Some of the important measures are as under. Early warning system. The early warning system, EWS, is very essential in disaster risk reduction. The essential component of early warning system are risk knowledge, monitoring and warning services, dissemination and communication of warning and response capability. Thus, in order to save lives from lightning, it is necessary to develop early warning system and moreover dissemination of early warning information. Case study of Jharkhand. During the year of 2008 to 2010, a pilot project of monitoring lightning and thunder was carried out in the state of Jharkhand. Lightning detection centers were established at different places such as RAC campus, ZRS Chianki, ZRS Darisai, KVK Jagannathpur, ZRS Dumka and Goria Karma unit. A mobile lightning detection unit was also established. Boltec LD250 sensors of 500 km resolution were used for the detection of lightning. Based on this study, an early warning system was established. With the observation from lightning detection centers, on-time warning was issued through various means such as hooters, SMSs, mails, television, radio and agromet advisories. An Android app named WeatherBug was also used to issue 30 minutes to 3 hours advance warning against lightning. This was a significant step towards averting lightning risks. Installation of lightning arrestors. Lightning arrestors are devices that arrest lightning before its formation and hence there is no sound and light. Based on the expected intensity of lightning, the lightning arrestors are installed in a series to make an area lightning safe. Again, in the state of Jharkhand, the building bylaws of 2016 makes it mandatory for all G+2 and above buildings to install lightning arrestors. Lighting protection system. Air termination system, down conductor system and earth termination system are widely used as lighting protection systems in the country. Air termination systems consist of rods, spanned wires and cables or meshed conductors as standalone or combined as required. Air terminal is a type of strike termination device intentionally installed for the purpose of intercepting lightning flashes. Lightning protection 2016. While using the air terminal method, air terminal tip must be located at not less than 10 inches above the protected object if the internal spacing is not more than 20 feet between air terminals. Figures 4 and 5 illustrate the typical roof protection for buildings with flat roof. Air terminal spacing can be either 20 or 25 feet depending on terminal height. Perimeter and down conductors with the connection R to grounds rods are also shown. Rolling sphere design. This method uses an imaginary spherical ball with 150 feet radius that rolls over the building structure, touching only the tips of air terminals mounted on the roof. This dimension is based on the fact that lightning strike distance near the surface of the earth is about 150 feet or less. When using spherical shape to determine the zone of protection for the buildings, All possible placements of the sphere on the structure shall be considered for terminal placement. A protected building that is more than 150 feet high will provide protection for lower elevation roof areas of the adjacent or connected structure when the lower structure roof is protected by the arc of the sphere that is tangent to the side of the protected building and to the earth. This method has been shown in figure 9. Protective angle method. The protective angle method is based on a ratio of upper building height and size to lower building area height and size with the location and placement of air terminals. If not more than 25 feet to the lower eaves, a 2:1 ratio, that is 2 horizontal feet of building coverage for each vertical foot in elevation, can protect the lower portion of a building or out to the first air terminal location on a large roof structure. If not more than 50 feet to the eaves or to the perimeter air terminal location on a higher flat roof, the lower roof is protected by the higher roof in a 1:1 ratio, that is 1 foot horizontal coverage for each vertical foot from the upper structure. This ratio would also cover the larger flat roof of the first air terminal based on the height ratio. Figure 10 shows the application of this ratio. Non-structural measures to minimize lightning strikes include: number 1, first aid. Majority of deaths in lightning takes place due to anoxia. Thus, first aid in the form of cardiopulmonary resuscitation or CPR immediately after the strike till proper medical care is available may prevent loss of life. Knowledge of CPR among the common man is necessary in case of emergency. Imparting the knowledge of CPR to common masses is an important part of enhancing community preparedness to lightning. Community preparedness. To develop a culture of safety and resilience, community preparedness is extremely necessary. The risk of lightning is not uniform across the country. Thus, it is necessary to follow different means to increase and enhance community preparedness. This can be done through different strategies proposed below. A. In areas having lower levels of literacy, the awareness program should be conducted by the people who are familiar with the local languages and customs. The message of dangers associated with lightning and lightning safety should be conveyed through songs, dramas, storytelling, etc. at the places where people gather often. Display of posters and photos with lightning impacts and safety rules can also be done. B. For communities with medium literacy rate, conducting public seminars and demonstrations in local language and use of posters with written safety tips should be used. Seminar should consist of basics of lightning, lightning safety and protection and first aid such as CPR. C. In areas with high literacy rates such as urban centers, awareness program can be incorporated with web-based information and educational programs which are ICT enabled. D. Incorporating the lightning safety in the school curriculum will streamline the knowledge at a formal level and help in dissemination of information. A judicious mix of above recommended strategies will definitely help in increasing community preparedness and building a culture of safety. Lightning Study Center or LSC. In order to prevent losses due to lightning incidents in the country, it is urgent necessity to establish a dedicated lightning study center that could actively involve in conducting research, awareness programs and information dissemination for lightning protection. The LSC will be able to work with international institutions and individuals and other regional organizations in close coordination. Through collaborations with entrepreneurs, LSC will be able to provide solutions of lightning protection at various levels. Sensitization of bureaucracy and engineers regarding lightning risks, lightning safety and protection can also be conducted by the LSC. Precautions. Following precautions are necessary to be followed during the event of thunderstorm and lightning. Number 1. Take shelter in an enclosed building. Its metal plumbing and wiring will conduct the electrical charge on the ground. Number 2. Do not touch anything that is plugged in. Number 3. Stay away from the open water. Also, do not bathe or wash dishes as water is good conductor of electricity. 4th. Stay away from open fields. It can be harmful as lightning can travel along the ground for about 20 meters. Stay away from trees, power poles or any other tall object. Rather than staying under a tall tree, taking cover in low bushes well away from tree is better plan. Sixth, stay away from metal objects such as fences, umbrellas, farm equipments and outside of cars and trucks. Be aware of overhead power lines. Seventh, while driving, stop the car in a safe spot. Stay inside a car with the windows closed and do not touch any metal. Installation of light protection system is necessary to protect from any direct lightning. The following do's and don'ts are essentially required for any community affected by lightning. Do's and don'ts on thunderstorms and lightning. If you're outside, number 1, go inside when thunder strikes. Number 2, stay individual, stay safe. Do not lie down in open, rush to a safe shelter. Fourth, if caught in lightning, bend down in a rounded shape. 5, keep away from trees or open areas, prevent disasters. 6, mountain tops or highlands are dangerous during thunderstorms, get down immediately. 7th, flying kites or playing in the open areas may be dangerous, avoid doing so. 8, avoid using umbrellas, fishing rods, metal sticks, etc. 9th, if you are in water or swimming pool during thunderstorms, immediately rush out. 10th, if you are in a boat or a steamer, go ashore to a safer shelter. If you are inside, number 1, it's dangerous to use plugged-in telephone or electrical or electronic appliance. Avoid using them during lightning and thunderstorm. Avoid using all the electrical appliances or wired gadgets during thunderstorm and lightning. Number 3, install lightning conductor in your house or office. It can save you. 4th, moving barefoot inside the house may be dangerous. Wear rubber slippers. Let us now learn about the institutional mechanisms to address lightning and thunderstorms in India. Certain initiatives have been undertaken in the institutional framework to address risks of lightning and thunderstorms. Indian Standard Code of Practice for Protection of Buildings and Allied Structures Against Lightning outlines the technical aspects of lightning. It mentions how to assess risks of lightning strike and provides guidelines to determine if a structure is in need of protection. It also provides guidance on good building practices to prevent harm. Currently, lightning is still not recognized as a major disaster. It is not present in the national list notified hazards in spite of the alarming number of lightning deaths. It falls in the state notified hazard list of only select states like Jharkhand. As such, the reporting of lightning events and ensuing compensation mechanisms is not streamlined. Concentrated efforts to prevent and mitigate the risks are also in a nascent stage. Thank you.